In right triangle ABC shown below, altitude CD is drawn to hypotenuse AB. So triangle ABC is a right triangle where the right angle is located at C, and the reason is AB is hypotenuse, and the right angle is always going to be opposite of the hypotenuse. CD is an altitude drawn to hypotenuse AB, so therefore CD and AB will form a right angle because an altitude is always going to be perpendicular to the side that it is drawn from. Explain why is triangle ABC similar to triangle ACD. So I'm looking to see why the overall large right triangle is similar to the smallest right triangle in this diagram here. So the way that I will approach this, and I'm not saying that this is the way to approach it, but this is certainly the way that is most clear to me why that's the case. So looking at this, I can see that angle A and angle B, they don't have to be congruent. But I do know that A plus B must be complementary. They must equal to 90 because A plus B plus angle C here equals to 180, right? And since angle C is 90, that leaves us with A plus B is equal to 90. There are two other angles here that we don't know. We don't know this angle, which I'm going to call 1, and we don't know this angle, which I'm going to call 2. The other angle on the other side of the altitude there, that's also 90. So from this, okay, what I can do is I can say that angle A plus angle 1 is equal to also 90 degrees. Because, very similar argument, angle A plus angle 1 plus 90, I'm talking about the small triangle now, A plus 1 plus 90 must equal to 180. So we can conclude once again that A plus 1 is equal to 90. Looking at the middle triangle, the medium-sized triangle, so triangle BCD, right? We can make a very similar argument and say B plus 2 is also equal to 90. And then the last relationship is this, and that is 1 plus 2 must also equal to 90 because 1 and 2 make up angle C, and angle C is 90 degrees, so therefore 1 plus 2 is equal to 90. Why is this important? Why am I showing you all of this? Well, that's because if I take, and check this out, this is where the magic comes from, right? If I take this equation here and this equation here, and they both equal to 90, right? And I set them equal to one another. I say A plus 1 is equal to 1 plus 2. They both equal to 90, so therefore those equations must equal to one another. I can then conclude that A must equal to angle 2. This is important. I can then also conclude, right, similarly, if I take the second equation, this guy now, B plus 2, and set that equal to 1 plus 2. Because again, both of these equal to 90, right? And if I subtract both sides by angle 2, what am I going to be left with? I'm going to be left with B is equal to 1. So we have then in this triangle, if we can make this conclusion that angle 1 is really B and angle 2 is really A. Now look at this, right? Angle A has 1 marking and angle B has 2 markings. So therefore we can conclude that triangle ABC will be similar to triangle, what is that? ACD. Because of, again, angle-angle theorem. Both triangles are sharing 2 congruent corresponding angles. So what are those again? One more time, right? Angle ABC is congruent to angle ACD, and angle CAB is congruent to angle CAD. So again, we have two corresponding angles that are congruent, so therefore this must be true.